Namaste candidates. We often talk about correlation and slope when analyzing data. Both describe how variables move together. But here's the catch. While they might seem connected, they actually tell two very different stories. In this video, we'll understand what correlation really means, what slope represents, and how both can look similar yet mean completely different things. Before we talk about the differences, let's see where correlation and slope actually connect. Both describe a linear relationship between two variables x and y. They also share the same direction. When x increases and y increases, both are positive. And if x and y move in the opposite direction, both are negative. Interestingly, both the statistical tests for both correlation as well as slope, it actually reaches the same conclusion, whether the relationship exists between x and y or not. Okay, let's come to correlation first. Correlation tells us how strongly two variables move together in a straight line pattern. It measures how tightly the data points fit around that line. We call that the pattern fit. The value of correlation always lies between -1 and +1. The closer it is to the either end, the stronger the relationship. And one key thing, correlation has no units. It is standardized, which means it does not depend on your scale or measurement. Let's visualize what correlation actually looks like. Here you can see 6 scatter plots, each showing a different strength of relationship. So when the correlation is high, say close to 1, you can see 0.9 is there, then the points actually form across a perfect line indicating a very strong positive relationship. Okay. When of course it's close to -1, the line will slope downward. But when the magnitude is small, let's say like 0.23 or -0.235, the relationship is quite weak, or you can say almost random. So whenever they are closer to +1, -1, the relationship is stronger and more clear. Now let us understand what the slope tells us. The slope measures how much y changes when x increases by 1 unit. That is basically the rate of change. So unlike correlation, slope always has units like rupees per hour, marks per study hour, miles per gallon. It also shows how steep your line is. A steep line means a faster change. A flat line means a slower change. And one very important thing, slope is scale dependent. So when you change the units of your measurement of the data, the slope will also change itself. Now this is where things get really interesting. Both these graphs have a correlation of 1, meaning that the relationship is perfectly linear. But notice the difference. The slope on the left is 0.3 and the slope on the right is 0.75. That means both lines have the same pattern strength, but the rate of change is completely different. Correlation only tells us how well the points fit the line, not how steep the line actually is. That is what slope captures. Let us put correlation and slope side by side and compare them clearly. Correlation tells us about strength and direction, while slope tells us about the rate of change and of course direction as well. Correlation always lies between -1 and +1, but slope can take any real value. Correlation has no units, whereas slope always has units like, say, as I said earlier, rupees per hour, meters per second. Finally, correlation focuses on how consistent the pattern is, while slope focuses on how steep or scaled the line is. Both are related, but they answer very different questions. Now, one thing you may ask over here is that even slope can sometimes have no units. Yes, that is possible when both x and y will have the same units. Then slope can be expressed just as the ratio of y and x, or you can say change in y by change in x. Let us look at this real world example very closely, because this is where many students get confused. Both class A and class B have the same correlation between the number of hours of study and the marks obtained, that is 0.85. Okay, it means that the pattern between study hours and exam marks is equally strong in both classes. In simple words, in both groups, students who tend to study more tend to score more, and those who study less tend to score less. So the relationship pattern is equally consistent, you can say. But look at the slope. In class A, students gain 5 marks for every extra hour of study, while in class B, they gain 10 marks for every extra hour. The question is, how can correlation be the same? Yet class B improves twice as fast. So here's the trick. Correlation only talks about the strength of the relationship, as I said earlier, how perfectly the points follow the line. It does not talk about how steep that line is. Both lines can fit the data equally well. That is why correlation is the same, but class B's line rises more sharply, which means their marks increases at a faster rate for every extra study hour. Okay, so remember this, that correlation measures consistency while slope measures speed. Both are about the same relationship, but they tell us different parts of the story. So now you know, even if two lines on a graph look similar, they might not mean the same thing. Correlation shows how strong the relationship is, how closely the data follows a line. Slope shows how fast things are changing, how steep that line really is. The line may look the same, but the message it carries, maybe not. Next time when you see a graph, you'll know whether it is showing strength or speed. You can say pattern or progress. Okay? Thanks for watching. If this helped you understand the difference between correlation and slope, make sure to like, share, and to follow for more simple data and stats lesson. All the best. Namaste.